Hello my dear students, good morning, welcome back once again, hoping you all are absolutely fine. So today we will start a new chapter, that is fourth chapter, pressure in fluids and atmospheric pressure. Atmospheric pressure is the second part, so let's start the first portion, that is pressure in liquids. So first it comes about the pressure. So whenever there is pressure, thrust automatically comes, because in the previous standard, that is in class 8, we have already gone through about this pressure and thrust very well. So now let's recapitulate about it. What is pressure? We all know that pressure is a kind of force, isn't it? But it is not equals to force. Pressure is a special kind of force. Now why pressure is a special kind of force? What is the speciality in this special kind of force? Because pressure is always measured about the total number of force acting per unit area. Okay, that is pressure is equal to force per unit area. Now this force in case of pressure is generally called thrust. This force. Now what is thrust? We will keep discussing in this video. So pressure is measured about the what is the total amount of force exerted on any body per unit area. It is not about the force. If we divide, suppose total amount of force is applied on any surface, then if we divide it with the total amount of surface, it means the total amount of force acting in unit area. Now suppose here you can see, suppose there is a block, isn't it? Any solid block. It may be any huge box, isn't it? It may be of marble slab, any suitcase, whatsoever, anything else. Here it is rectangular in shape. Okay, it may be circular, spherical, or arbitrary in shape, doesn't matter. So here you can see, suppose there is an object, rectangular box or anything else. Now its weight is 30 Newton, and weight always acts in the downward direction. And suppose its area, that is multiplication of its length and breadth, is 10 meter square. So now its pressure is not 30 Newton, but how pressure is measured? That is what amount of force acting in its per unit area. So if we divide the total amount of weight, which is nothing but force, that is gravitational force, the force by which Earth attracts any body, any particle towards its center. So that's why it is called force. So if we divide the total amount of weight of the body by its total amount of area, we will get 3 Newton per meter square. So it means here the force acting on its unit area is 3 Newton. Clear? And this is the method. This is how pressure is generally measured. Okay. Now if we multiply with pressure with its total area, we will get total force. Okay, which is called thrust. So thrust is the net perpendicular force, total amount of force which acts perpendicularly, which is also called the weight of the body. Now what do you mean by perpendicular force? So it means that there is some other forces which acts in other direction. Obviously, otherwise if perpendicular terms is not so important, then we could easily say net force, but net perpendicular force. It means that there are some other forces which acts in other direction. Now it can be cleared from this diagram. Why perpendicular? Why we need to write perpendicular? So it means obviously force acts in other directions also. Now suppose there is a straight line AB. Okay, I am discussing in terms of mathematics. Suppose there is a straight line AB and we have chosen a point C above it. Now if I ask what is the distance of the point C from the straight line AB, we can draw so many lines. It is CA, CB, CE, CD, CF, CD. All these are the distance of the point C from the AB, isn't it? Obviously, because all these are length. AC, EC, from reaching point C through A, we can reach straight line AB. Also, we can reach by distance CE through CD. We also can reach through the path CB to AB and also through CB. So all this distance, if we follow CB path, CF, CD, CE, CA, by selecting all this path, by following all this path, we can reach AB. So we can say all these are the distances. Obviously, we can say, but in mathematics, what is the appropriate distance of point C from the straight line AB? that is the shortest distance, which is called the perpendicular distance, which is CD. Nothing the other, okay. The other distance are meaningless. Only if we talk about what is the distance of the point C, it means the actual distance, the appropriate proper distance is the shortest distance. Shortest means how we can reach AB in a short interval of time by following the shortest path, that is perpendicular. It's only possible if you draw a perpendicular. So here CD is the actual or the perpendicular, the actual distance of the point C from the straight line AB. Neither A nor ECE nor CA or CB. So exactly like that. In case of thrust, force can act in so many directions, CA, CE, CA, CB. But generally the force which acts perpendicularly up to a particular total area is called as thrust. So means thrust is equal to pressure into area, as you can see, which is nothing but its weight, because any object, solid object, exerts force in the downward direction. We all know that weight always acts in the downward direction. Since thrust is the total force acting, the total perpendicular force acting on any surface. So since this is total force, and which is nothing but the weight of the object. Clear? So this is thrust, net perpendicular force. Okay. So if you just take this example, if you think this example, you can easily remember it. So let's discuss about the units of pressure and thrust. Now since thrust is nothing but the another shape, we can say is, what can I say, it's another name, that is its nickname. Force and thrust are same persons, isn't it? So their units are same. That is in SI unit it is Newton, and in CGS it is Dyne. Then what about the pressure? Since it is force per unit area, so in SI, so it's first absolute unit. Now I have already discussed in the previous chapter, that is in gravitational, isn't it? Newton's law of gravitation. You have already learnt about what is absolute unit and gravitational unit. That is the force which by acting on a body of unit mass creates unit acceleration, then it is called absolute unit of force. Clear? So Newton per meter square. So absolute unit, so the absolute unit of pressure is the absolute unit of force by SI unit of area. So we all know that SI unit of force is Newton per meter square. It is a special term, a new name, it is called Pascal, which is written in this fashion, capital P and small a, this is Pascal. So Newton per meter square has a special name, it's called Pascal. So it means if 1 Newton force is applied on a surface area of 1 meter square, that pressure is called 1 Pascal. Clear? Now it's gravitational unit. The gravitational unit is the force by which Earth attracts any body of unit mass towards itself. It is called gravitational unit, which is nothing but its weight. Clear? So gravitational weight is kg force per meter square, or it is sometimes called kg weight per meter square. It means, okay, whatsoever. So it means if 1 kg of force is applied on at 1 meter square area, then it is called kg force per meter square. It doesn't have any special name. Now moves on to CGS unit. Again, its absolute unit is the CGS unit of force divided by CGS unit of area, that is nothing but dyne per semi square. It also doesn't have any other special name. Gravitational unit, again, that is gram force divided by second square. Okay, just in place of kg force, it is gram force and divided by semi square. Now the important part is that the factors affecting pressure, means the factors on which pressure depends. So we can clearly see pressure depends on two factors, that is thrust, that is the total amount of perpendicular force, and the area. So we can clearly see from this pressure equals to thrust by area. So pressure is directly proportional to thrust. If thrust increases, pressure increases, thrust decrease, pressure will decrease. You can clearly see in case of constant area. If area is kept constant, you can see at first force is 50 Newton, so the pressure is 5 Pascal. Then if we reduce the force, that is thrust, that is 40 Newton, you can see pressure also reduces when area is constant. Now second part is the most important. It has a very wide application in our daily life. Surface area. Now you can see if thrust is constant for a particular definite force, that is weight, isn't it? Pressure is inversely proportional to area. It means if surface area is less, more amount of pressure will exert, and if surface area is more, isn't it, less amount of pressure generally applied on that surface. There are so many examples. You can see, suppose there are some amount of sand. Okay, same amount of sand, figure A and figure B. You can see there is a heap of sand. Now at first on that sand, a brick or you can see any object. Here it is given the example of brick. A brick is generally placed light on it horizontally, isn't it? So now in this case, you can see, since its surface area, you can see its surface area. Its surface area is more. So since surface area is more, so its pressure, okay, weight is same, because for a particular weight, because since it is a single brick, so obviously weight is for the same weight is not going to be changed on a particular planet, on a particular surface. So you can see here surface area is more, it is covering the more surface area in contact with the sand. So in this case, the pressure, the brick will exert less pressure on the sand. So that's why it doesn't sink, get inside the sand. Look at the figure B. On same heap of sand, initially we just place the brick horizontally. Now if we keep it vertically, you can see slightly the bottom surface is slightly sink, slightly get inside the sand. Why? Now in this case you can see very less amount of area. The surface area is very less as compared to previous figure. So since area is very less, so more pressure will exert, isn't it? So due to its higher pressure, due to less area, the brick will exert a larger pressure on the sand. So and due to that pressure, it will just get inside or sink into the sand. Generally, there is same kind of example that if any person, when we stand on a heap of sand or any beach, isn't it? Our legs generally sink inside the sand. But if we lie on the heap of sand, isn't it, or any mud, isn't it, flat, then we don't sink so much, isn't it? Now, if we stand on the very muddy surface vertically, then we generally sink. This is the same reason, because when we lie flat, surface area is more, so less pressure is exerted. Now here remember one thing, weight is same, there is no change in weight. Why? Same brick, a brick cannot have two weights. Clear? Now a person, when we lie and stand, the weight is going to be same, because when we lie, it doesn't mean that someone's weight is 60 kg and when he will stand, its weight will just change. Not same person, same object, weight is going to be changed. Weight is not going to be changed, but surface area is changing. So same weight, for larger area, the pressure is less, whereas for a small area, it exerts more pressure, since they are inversely proportional to each other. There are so many examples, isn't it? Now you can see pressure. Suppose the weight of a person is of 50 kg, which is called gravitational unit, but in SI unit it is 50 Newton, and the area is, suppose, the 10 meter per second square, isn't it? When it lies, suppose a person is lay down on some heap of sand, so its area is 10 meter per second square. Clear? So the pressure exerted on it is 5 Pascal. When the same person will stand on the heap of sand, look at that, the area will just reduce. Look at the pressure, huge amount of pressure, double. The pressure is almost double, and he will sink into the heap of sand or mud. So many examples. When we generally use nail, isn't it, or a pin, isn't it? You can see it's the one end, isn't it? The end of its not is the top, isn't it? The back end of it is very sharp. It's made very sharp. Pin or any safety pin or any nails, so that, isn't it? It is because of the less surface area, pressure is exerted more pressure is exerted. So by hitting the hammer, by using only a less effort, it can easily penetrate the wall, isn't it? Just like this, it can easily penetrate the wall. Why? Look at this surface area, just like a point, sharp edge. So in this case, what amount of pressure will be pressure will be more. So it means we don't need to apply a huge force, so don't need to waste much amount of energy. By applying a small amount of effort, we can easily, by hitting the hammer, it can easily penetrate the wall. But if we try to hit here, isn't it? It is not possible, because it's a flat surface, isn't it? So we need to apply a huge amount of force, which is generally doesn't happen. Again, in case of, you can see the two blades, in case of a knife, or isn't it, one edge, one surface is generally blunt, other is sharp, isn't it? Just like, isn't it, very sharp. Why? So that because of this very sharp edge, isn't it, very sharp edge, one side is very flat and whereas other is very thin, very sharp. It is just like this. Other surface is generally the incline of two surfaces, isn't it? One surface is very sharp, other is blunt, other is very sharp. Very sharp. Why? Because of this very sharp edge, this area is very less. Clear? So pressure is more. So due to this more pressure or larger pressure, objects can be easily cut with the knife or in tools like that. Okay. This is the application of the area. This is the laser area. But so if the area is less, we can decrease the amount of pressure, just like the nail, safety pin, isn't it? Which are generally very useful instruments in our life. Now, obviously, again, the way to increase, way the decrease of pressure is also important in our life. If we increase the area, okay, pressure will be decreases. So many examples. Generally, the base of a house, when any tall house or any house is generally made, a tall house, its base is made wider. Why? Since base is made wider, so area is more, so less pressure will exert on it, isn't it? So it will not be affected. So it will not affect in the construction of the building. If the area is made very less, so pressure will be huge. The upper floors will exert a huge pressure, so the building may collapse in any sort of disaster. Okay. Now, in case of the bottom area of bottom area of, in case of any, what can I say, dams, they are also generally made wider, so that less, okay, so that less amount of pressure is generally applied on it. Then we will discuss about it in case of pressure in liquid. Again, camel can easily walk on the sand in desert because of the broader feet. Because the broader feet, area is very less. You all have learned, isn't it? Gone through about it in class 8. So since that, because of the broader feet, area is more, so they exert less pressure and they can easily, so their legs doesn't sink, isn't it? So that legs doesn't sink into the sand and they can walk easily. So all these are the fundamental concept about pressure and thrust. Hope you have understood in the next video.